And so we have a special guest, Matt Wengel from Lemelson Vineyards. Yes, he's just waving, in Oregon, to talk to us about this topic, which is his absolute biggest passion, I hear. So to give you a quick brief on Matt, Matt Wengel, he's from California. He studied viticulture and enology at University of California, Davis. He's been making wine for 16 years now, mostly Napa, Sonoma, also in upstate New York, Chile, and South Africa. He's been at Lemelson now for 6 years and spent a lot of his early part of his career exploring different wines, wine regions that revealed what he wanted to focus on, and that's organically farmed Pinot Noir in Oregon. Stylistically, he likes making wines with minimal intervention to promote terroir. So it's gravity processed, no fining, no filtration, no additives, and no inoculation. So hello, welcome, Matt, and over to you to start this exciting discussion on microbiology in wines.
Can you see my presentation and the mouse?
Yeah, we can.
Sumi, I don't know if you realize this, but you just compared wine microorganisms to the coronavirus. That is a sin. These bugs are beautiful.
I extended it.
You know,
and that's the beauty and the ugly is, right?
You know, I love microbiology with regards to winemaking. And when I spoke with Sumi about a month ago, she gave me the opportunity to choose a topic. And, you know, instinctively as a winemaker, the go-tos are your organic viticulture, your sustainability, red winemaking practices, the usual suspects. But today we're going to talk about something different. We're going to talk about wine bugs, not coronavirus. Many of you are all professionals, are familiar with Saccharomyces cerevisiae. This is our wine yeast seen under a microscope. They make our wine possible, period. If you're familiar with them, you might know these little buggers over here. These are Enococcus enos. These are our malolactic bacteria. But what we seldom talk about are the dozens and dozens of other wine-related microorganisms, some of which are good, most of which are bad, some of which are just downright ugly. So the scope of this presentation today, what I want to talk about is bring them all together and talk about how we need to control not just your Saccharomyces, not just your malo, but control them all because they all work together and in some cases work against each other. Before I did that, I just wanted to give you a little background on Lemelson Vineyards. This presentation isn't about Lemelson specifically or really Oregon specifically, it's microbiology, but I gotta throw in our plug, right? But this is a picture of our winery. We're located in the heart of the Willamette Valley. Founded in 1995, family owned and operated since day one. The handsome gentleman in the upper right-hand corner is my boss, the owner, Eric Lemelson, who is in addition to being a winery owner, an environmental lawyer, climate change activist, as well as an energy policy activist. So this is a gentleman who's really striving to make the world a better place for future generations. Which for me, I respect the guy a lot for that, and I hope you do as well. We have 6 certified organic estate vineyards, as you can imagine, with an environmental attorney. You know, we've been farming organically before it was cool. We have a state-of-the-art gravity flow winemaking facility pictured here that utilizes 4 tiers of gravity flow, which is a topic I can present on half an hour easily in and of itself. We produce about 15,000 cases of wine each year, 90% of which goes to Pinot Noir, with the balance to Chardonnay, Pinot Gris, Riesling, and Rosé. And then this is the Willamette Valley. If you're not familiar, I'm sure you are, but Oregon is in the northwest of the United States, sandwiched between Washington and California. Within the state of Oregon, the Willamette Valley is in the northwest part of the state. It is a Class 1 cool climate viticultural area. With a heavy maritime influence coming from the Pacific Ocean through the Van Duzer corridor. To date, there's about close to 700 wineries in the Willamette Valley, and they're largely concentrated in, you guessed it, the northwest part of the Willamette Valley and the several sub-AVAs we have here. Lemelson Vineyards is located in the Yamhill Carlton AVA here. with vineyard plantings as well in the Dundee Hills and Chehalem Mountains AVAs. So we're going to talk about wine microbiology from my perspective. I'm not a microbiologist. I studied microbiology. It's not my specialty. Obviously, it's related to wine, but this is from a boots on the ground winemaking perspective of microbes through the production process. So it's important to talk a little bit about that process before we get into it. As I mentioned before, we are a gravity flow facility, the entire point of which is that we seldom, if ever, use pumps on our wine to prevent bruising or potential damage. We are uninoculated, and I know that term, there's a lot of terms, native fermentation, vineyard fermentation. By uninoculated, it is what it is. We don't add commercially purchased wine yeast or commercially purchased freeze-dried malolactic bacteria to assist us. We use ambient microorganisms. One of our signatures for the area and as a winery for Pinot Noir in the Willamette Valley is we do extended skin contact time, averaging about 30 days on the skins for Pinot Noir. We're much more standard, about 10 to 14 days of skin contact. So driving for more of extracted style of Pinot Noir, we couple that with extended time in barrel, 16 months versus the standard 8 months. So that makes us relatively unique because we do that with all of our Pinot Noir programs. We don't fine our wines, no animal products are used. I prefer to control the tannins during fermentation and not have to modify them after the fact. And lastly, we're unfiltered. That is not, I do not believe if you filter your wines, you are inferior by any measure. I filtered wines for actually most of my career. I just happen to think with Willamette Valley Pinot Noir, unfiltered makes a better wine. The reason I capitalize that is because as it pertains to this presentation, your silver bullet in the microbial world is filtration. You get bad microorganisms, you can filter the wine, they're gone. When you choose not to filter your wines, you lose that control, which means a much more emphasis has to be placed on the winemaking process to ensure you never have to get to a point where you would need to filter. This discussion needs to start in the vineyard. Microbes, the microbial discussion for wine starts in the vineyard, and more specifically, it starts on the surface of the berries you see here, the top of which is Pinot Noir. We will see high populations of our wild yeast. These are Clecera, Hanseníaspora, Brettanomyces, Hansenila, Mechnicowia, Candida, Pichia. I'm sure you'll remember all those. I never do. They are fermentative yeast, but they are also quite weak. If they can ferment, they generally can only tolerate up to 2 or 3, 4, maybe 5% alcohol, which means that these wild yeasts are not going to do an entire fermentation at your winery. These are not going to ferment your wine and create wine for you. We also have populations of mold on the surface of the berry. Most important of which, with the case of cool climate viticulture, is botrytis, which I'm sure you're familiar with the production of late harvest wines where it's desirable. But in the case of Pinot Noir, it's absolutely bad, principally damaging the surface of the grape itself, depleting nutrients, but none of these molds would survive in the winemaking process. We also have bacteria. We have the bacilli, which are largely originate from the soil, but lactic and acetic acid bacteria, none of which are good. I don't want any of that in our resulting wine. Those really none of these, to be quite frank, do I want in the winery. I just live with them because they're out there. It's nature after all. These bacteria, they exist in very, very small populations on the surface of the berry when they're intact and healthy like this. When we have our other nefarious pests, namely wasps, insects, birds that come and stick their little stingers or whatever to try to suck that sweet nectar out, puncture the berry, laying all that juice out. As soon as that sugar comes out on the surface of the skin, all of these guys are going to want to gobble that up. Their populations are going to blow up, and you're going to lead to a rot scenario where you have large populations of this that are going to cause you problems in the winemaking process down the road. This is bad. Lastly, Saccharomyces cerevisiae. Look, a lot of people like to, and I've heard people say it, our wines are made with vineyard yeast. I respectfully disagree. I'm not going to discredit you as a winemaker or a wine owner or a wine writer you may believe that. It has been shown that Saccharomyces cerevisiae is found on the surface of grape skins, but it's very difficult to find. And when they do find it, it is in extremely low populations. So the odds of those low populations successfully completing a fermentation at your winery on their own are slim to none. You know, I was watching a Netflix movie like 2 nights ago, and it made me think about this because I was working on the presentation at the time. But it was a movie, and there was a couple, a man and a woman, his pregnant wife, were astronauts in space in a spaceship. Earth becomes uninhabitable, humanity dies, and they're left alone to go to a distant world to settle it and resume mankind. And I think it's a very similar analogy, right? Like, what do you think the chances of 2 people going to an uninhabited planet have to repopulate a human population? You need a population base when you're going on an expedition like that. So I don't buy it that the Saccharomyces cerevisiae comes from the vineyard. And if it is coming from the vineyard, it's because you're composting vineyard waste into the vineyard via compost. And you're actually inoculating your vineyard with Saccharomyces from your winery. So it's kind of working backwards against itself. But anyway, this is our first control point, because I do want to talk about how we treat these things and these problems as they arise. In the vineyard, it's quite simple. It's our vineyard spray program, right? As an organic vineyard, our spray is sulfur. You're going to hear sulfur as a control for microbes throughout this presentation because it's such a wonderful antimicrobial agent. We spray sulfur on the surface to keep these populations low. It doesn't kill the yeast and bacteria or the mold. It just keeps them from growing into unmanageable levels. This is a couple pictures of our winery. We pick all of our grapes by hand into little small yellow bins, which production staff across the West Coast call effing yellow bins, FYBs. Not a wonderful acronym, but they call it that because it's very labor intensive and you have to pick them up one by one by one by one. So here in the production cellar, the forklift lifts this pallet of FYBs, yellow bins, to the top. They're dumped on our sorting table here, sorted by our staff, and dropped literally berry by berry into the tank via gravity. So this is step 1 of the gravity flow process. This whole platform, we call the Enterprise, is on wheels and can move up and down the entire length of the cellar, spin 360 degrees about the axis at the top. And I'll show you a video of this, but it's a one-of-a-kind piece of engineering, and it's the winery was built around it. And it's really a kind of a beautiful piece of equipment. But most importantly, this is our second stage of quality control in the process, right? So the grapes have arrived to the winery. This, I would tell you, unlike the surface of a grape skin, you don't have to be Sherlock Holmes to find Saccharomyces cerevisiae in a winery. It's on the walls, it's on the floors, it's on the tanks, it's on the people, it's on me right now. When you walk into a commercial winery, no matter how well you clean it, you are effectively inoculated. So as far as I'm concerned, when these grapes leave the vineyard and enter this winery, they are inoculated with our fermentation yeast. The other control here is sorting. So when we see this cluster coming across the sorting line with presumably high populations of these negative creatures here, we take that cluster, we toss it, and we compost it. It doesn't go into fermentation. If I suspect that there's going to be high populations of bacteria, I will add more, or yeast, I will add sulfur in the form of like a liquid potassium metabisulfite principally to control those populations, much like we use sulfur out in the vineyard, just a slightly different form. I will not use SO2 if my grapes look like this. I am happy with natural populations of these. I don't try to kill them. I only just don't want to have inordinate amounts of them. So here's our Enterprise. I'm going to fast forward, but just see how wonky this thing is. Go, go, go. But you see that, that's the sorting platform spinning around. It just filled this tank. It's driving all the way down. It's going to spin, and now it's going to fill that tank down there. So this tank can sort grapes delicately into all the tanks in the fermentation room. Quite remarkable. Oh, nope. I like analogies. That's going to be a theme. As soon as those grapes go into the fermenter, those grapes that were intact and hopefully healthy break apart. The juice leaks out. The sugar, all the microorganisms that were on the surface of the grape skin are now in contact with an abundance of resource, right? Sugar for all. You know, this is a land of plenty. You can refer to it as utopia. You know, here are all your other microorganisms. You got Simba up here. They're all happy. They're not eating each other. Their populations are low. There's just plenty to go around. We have our cave people over here playing with some wild dogs. They have their clubs. They're cute. They're going to start fermenting as well. As I mentioned, they can ferment to some strains up to 3% generally alcohol before they succumb. But we have another player, right? This is a much more evolved state, as my analogy here. More evolved than our cave people. These people are actually smelting bronze, maybe. And this looks like a sword cast. So these guys are preparing for war. This looks like Bronze Age. They're getting ready for a conflict. And as soon as their numbers are high enough, these poor guys aren't going to stand much of a chance. Saccharomyces cerevisiae, as I mentioned before, present in large numbers at all commercial wineries, regardless of how clean. They conduct a vigorous fermentation, produce lots of heat, reproduce quickly. They behave predictably. They're very strong. They have a very strong tolerance for ethanol, and that's actually a defense mechanism, right? If you can produce alcohol that kills everything around you, and you yourself can tolerate it, it's a way to make your cells dominate whatever atmosphere it might be. In this case, wine. They are anaerobic. When fermentation starts, you're converting your sugars into ethanol, but you're also producing heat, and you're also producing large amounts of carbon dioxide gas, very large amounts of carbon dioxide gas. That carbon dioxide gas completely displaces all oxygen in the fermentation vessel. At that point, the environment turns anaerobic, devoid of oxygen, and in which case a whole nother class of these guys that require oxygen to survive are gone. They are also SO2 tolerant. So if we have contaminated grapes coming into the winery, I need to add SO2 when we're sorting it. I can add that SO2 and not worry about that impacting these guys, at least as much as it does the other organisms. Saccharomyces cerevisiae is great because almost unilaterally across the board, they produce delicious esters and fruity flavors with very low instances of off character. So this is a vulnerable point for our utopia. I Google imaged, vulnerable cartoon funny. So you're gonna see this guy a couple times throughout it. But when you see this guy, this is an instance where as a winemaker, you're paying attention and things can go wrong. So right now our juice is vulnerable. We have diverse microflora, largely unchecked by one another because of their lack of populations. Again, we're not inoculating, so there's no large armies in this mix. Our wild yeast can start producing some flavors for complexity in that limited time. If they can ferment up to 5% alcohol, that's close to a third of the total duration of fermentation, right? If a wine finishes at 12%, they can finish all the way up to 5. They have an impact. They can have an impact, and it can be fruity, it can be estery, it can be spicy. More often than not, you have a potential for volatile acidity in the form of acetic acid, vinegar. Not delightful at this stage. Ethyl acetate, a lot of them can produce that in high concentration. It smells like fingernail polish remover. Do you want to drink that? Other off flavors they can produce, I just lump together and I define it as funky. This wine's funky. And these wild yeast can produce these in abundance if their populations are high. So at this point, if you suspect your wild yeast populations are high, you need to intervene. I like to do a cold soak for a period of 4 days and have a slow start to fermentation. But if I know that our wild populations are perhaps getting out of hand, in a commercial, and if you inoculate, that's your time. At a winery like ours where we don't inoculate, I have other tricks up my sleeve. So generally speaking, I'll pick the first tank of the year as a very healthy site. I'll get that fermentation going. That tank will basically serve as an inoculum for a tank that might be in trouble, where I can transfer juice over to the uninoculated tank, basically transferring over fermenting Saccharomyces cerevisiae to get it going. And this is a case study, right? So this is a report, confidential, but I trust you guys. Last year there was a tank, and we used the enterprise. We sorted the grapes into the tank. The next day when I was doing my rounds, smelling through the tanks, I smelled the fingernail polish remover at the headspace of the tank. Immediately, I knew that there is wild yeast, in all likelihood, perhaps a bacteria producing this character. I knew that the Saccharomyces were in their infancy. So in an attempt to save this tank before the ethyl acetate got too damaged or irreparable, I pumped yeast from active fermentation from another tank that was fermenting side by side. In the old days, as little as a decade ago, to find out what was in our wine, I had to put it in a microscope. And this would be what it would look like if you had, here you have these big white globules are your yeast. I can't, unless you're a microbiologist, you're not going to know if it's Saccharomyces cerevisiae or Spora. These little dots here are bacteria, so you can see the large size disparity. Bacteria are quite a bit smaller than the yeast. In the modern times, I have a report that's called a scorpion. I send a sample, 50 milliliters of wine or juice to a professional lab, and they use polymerase chain reaction, PCR, just like they're using to test for COVID-19. They use DNA analysis, and not only tell me what microorganisms are in that sample, but how many of them there are. That sample turnaround takes about 3 days, which is why I didn't wait for this before I pumped in the Saccharomyces cerevisiae to save it. But here it shows pretty much what I predicted. 1.3 million cells per milliliter of Hensenius spora uvarum, very capable of producing ethyl acetate to disastrous quantities if left unchecked. Alcohol tolerant just to 3%, maybe 4%. So that to me means that our principal control was to get Saccharomyces cerevisiae in there and get me that 3% alcohol as quickly as you can. We also have acetic acid bacteria at relatively large numbers for a young tank such as this. While the Saccharomyces are destroying the Hensenius the Hensenius spora populations with alcohol, they're destroying the acetic acid populations, bacteria populations, by removing the oxygen via CO2 production. Double whammy. Aren't yeast amazing? All right. We're now at total domination phase of a fermentation by 3 to 5% ethanol. Saccharomyces cerevisiae is your dominant life form. By the end of fermentation, it is almost a pure culture. Our poor Simba, our cave people, they're all gone. Effectively all gone. Our job as winemakers at this stage is to make sure our now modern society of Saccharomyces cerevisiae is well fed and completes its fermentation, does not get stuck. I can go off on an entire rant on stuck fermentation, so I gotta not jump down that hole. Keep the temperature good, don't let it get too cold, and most importantly, don't let it get too hot. The yeast can produce enough heat to actually kill themselves. But I like this picture. It doesn't look beautiful. There are no animals, there are no other life forms. The dominant life form is the Saccharomyces cerevisiae. They've evolved to a state of industry, billowing off carbon. Fun fact, 1 liter of must creates 60 liters of carbon dioxide gas. So in a way, it's actually quite fitting, right? The yeast themselves in the fermentation are quite a bit on the heavy carbon emitting side. In fact, we're looking at ways in the industry, not me personally, but of capturing this carbon from the fermentation and limiting our carbon footprint. That's another discussion. But anyway, this is where our yeasts are in the middle, in their peak of dominance, no other life forms. End of fermentation. Nutrients are depleted, ? This is the end of Saccharomyces cerevisiae dominance. I did not say that they died at the end of fermentation. They're still alive. Right before the end of times here, they go to their local grocery store and absolutely hoard the heck out of toilet paper, Kleenex, renew their subscription to Netflix, and bunker down. They're going to live in the fermentation. They're going to live in the wine for years and years to come, or for months and months to come. But they are not dead. They're just effectively dormant. But with them stepping out of the picture, the opportunity is there for other microorganisms to enter the equation. Oh, there he is again. We're now in a high ethanol environment, which grossly limits the amount of microorganisms that can grow in the wine. You're never going to see this atmosphere turn into a utopia type where lots can thrive. There's very little nutrients. There's renewed oxygen. The yeast are no longer fermenting. They're no longer producing carbon dioxide gas. Unless you're very careful, oxygen can get back into the equation, which opens up all of the oxygen requiring microorganisms. What we call dry is 2 grams per liter residual sugar. Professionals, such as yourselves, can probably determine that that's a little bit sweet to the palate. But what I'd like to point out is some strains of Saccharomyces cerevisiae can't ferment to less than 2 grams per liter. If you're leaving 2 grams per liter of sugar in, let's just say, a wine barrel being 228 liters, 228 liters times 2 grams per liter, you got close to a half of a kilogram of sugar, a pound of sugar that's sitting in that dry barrel. That's plenty for other microorganisms to thrive on. The ones you don't want, mind you. So here are the bugs that can become a problem. Some of the bugs that can become a problem in the post-fermentation universe. Of course, Enococcus ini, RMML bacteria. It's time to shine, buddies. We have Saccharomyces that could, these guys, they're not coming from the vineyard in all likelihood. Some of them might, but largely this is because of contamination from winery equipment. This is where cleanliness is another one of your controls. Keep your winery clean. Dirty equipment can lead to the spread of these guys. So you got your Saccharomyces, a yeast that can ferment in a finished wine bottle. It's a scavenger. You have your other lactic acid bacteria in Pediococcus. You have your acetic acid bacteria that can turn your red wine into vinegar. Scary stuff. But they're all scavengers and can potentially thrive. And there's one I'm omitting. This is Brettanomyces. I don't know if these analogies are amusing or not, but for me, Brettanomyces is the Terminator. It is big, it is tough, it is resistant to potentially very high levels of sulfur, which takes that out of the equation. It is very alcohol tolerant. It is able to scavenge for micronutrients. It can outcompete all of the other organisms. When it's in your winery, it stays for good, like your Saccharomyces cerevisiae. It also produces compounds called 4EP and 4EG. In low concentrations, the Brettanomyces, the amount of 4EP, 4EG can smell floral, can smell fruity, can smell delightful. It's why Brett is inoculated and used in beer production at low alcohol to make really tasty bready style other alcoholic beverages. If these guys get out of control and that level of 4EP, 4EG goes too high, you're going to start transitioning that aromatic profile to barnyard, to Band-Aid, to horse blanket, which as a complexity note, may not be a bad thing. Some of my favorite wines and the best wines in the world have Brett impact. That's just a fact. The problem lies is if it goes out of hand, it can become your dominant flavor profile and totally overrun fruit. This is where Enococcus comes in. It's our preferred scavenger of choice. In this post-fermentation landscape, we want these vultures to come in and do their job. Not a pretty animal, but I think a fitting one. Cockroaches might have worked, rats, but I didn't want to show you pictures of that. I'm representing Lemelson Vineyards and I'm showing you Terminators and vultures and all sorts of unfavorable imagery. Probably not the wisest move, but it's fun. But Enococcus ini converts our malic acid to lactic acid, a general softening of the acid profile of the wine. That's nice. Production of diacetyl, your buttery character. Could be desired, could not be. There's a wide array of different malic acid bacteria that can promote fruit, mouthfeel, texture, low levels of diacetyl, high levels of diacetyl. And that's all good and dandy. But this is what I would argue is a chief reason we use malolactic bacteria from a winemaking perspective. It scavenges the micronutrients left behind by the Saccharomyces cerevisiae. That barren landscape becomes even more barren and less favorable to organisms like, well, oops, Terminator. If we get our malolactic bacteria in before these guys, we have a chance of controlling this population. They're SO2 intolerant. So when you get to this phase and you're like, okay, we have 2 grams per liter of sugar. I want to age this wine for 15 months. Why don't we just add sulfur? Well, it'll take out all these guys, including your ML bacteria, and make a very happy environment for the Terminator, which can tolerate the SO2. You've just stabbed yourself in the back. Our barrel rooms, I don't know, just pretty underneath our cellar at the bottom for the gravity flow. So finished wine and bottling. The most important thing you can do is as soon as your malolactic conversion is done and your bacteria have scavenged all the micronutrients, get sulfur back into your wine. Maintain 0.8 molecular free SO2 or SO2. That is so critical because at this point, I said, Brettanomyces is resistant to SO2. It doesn't mean it likes it. So if you maintain your wine with appropriate levels of SO2 and keep it cool, you don't want your wine to get warm. You want to keep it sub 60 degrees Fahrenheit. Apologies, I don't know the centigrade conversion on that. This is critical to controlling microbes, particularly acetobacter that turns your wine to vinegar, your acetic acid bacteria. You want to eliminate reduced oxygen exposure. This is a topping a barrel. So over time, wine will evaporate out ethanol, leaving behind a headspace that becomes saturated in oxygen. By refilling it with wine, you eliminate that headspace. Find unwanted microbial populations and treat them as soon as possible. So filtration is an excellent tool, particularly once you have finished wine. You might use sorbate, which inhibits fermentative yeast used in juices or sweet wines to stop any unfiltered juice or sweet wines to stop the yeast from going. You have Velcorin, which is a newer invent that basically kills all the life forms in the wine. It's a pretty potent poison, but it breaks down into carbon dioxide and I believe methanol that are totally benign. What we do here, because we do have, spoiler alert, I do have Brettanomyces in my cellar. I hate to admit it. I use chitosan. So this is a derivative of, I believe, a polysaccharide derivative of Aspergillus niger, a fungus. And it basically, when you add it to the wine, it glops to all microbiological, be it Brett, Enococcus. It binds to them and then precipitates to the bottom of the tank or barrel. After a period of settling, you rack the clean wine off the top, and that's the way you filter out your unwanted populations without actually filtering. You do need to rack. And then just a couple of instances of scorpions that I've seen throughout the years. This is beautiful. This is our 2018 Sturmer Vineyard right before bottling. Lactobacillus populations less than 10. They never say 0, so less than 10 means they didn't detect it at all. So that's good. Pediococcus, none. Brettanomyces, thank goodness, none. Saccharomyces cerevisiae. At the peak of ferment, we're probably at the 10 million plus cells per ml. We're now down to 5,000 at the very end game after 16 months in barrel. No zygo that can ferment in the bottle. But we have tons, the Enococcus, those vultures, they stick around. It's 5.6 million, maybe it's 560,000. The acetic acid bacteria is not a problem at those low concentrations. You gotta take into account the density, right? In a bottle that's largely anaerobic, these are not going to thrive and make that bottle into vinegar in decades. This is not so great. 2019 was a tougher year. It was wet. Huge populations of acetic acid bacteria. Enococcus is going. 14,800 cells of Brettanomyces per ml. Anything greater than 1,000 gives you the creeps, the chills. You're having trouble sleeping at night. This is a problem. The 4EP, 4EG is going. This wine did not smell like Brett, but it's on its way to doing that. We have our sac, but we also now have zygo. So this is a fairly compromised sample. I treated it with chitosan, and afterwards it looked similar to this. It's a magical product. No filtration needed. So really, as I see it, how am I in time? I'm sorry, I didn't start my stopwatch. I'm just gonna keep going. We're good on time. Thumbs up. Yeah. A winemaker's job, keep fruit as healthy and unspoiled as possible. Point 1, don't control the microbes in the vineyard. Ensure a healthy and appropriately timed fermentation. Absolutely. Same goes with malolactic fermentation. Monitor your microbes. Use your eyes and your nose regularly. Sending out scorpions, looking at it under a microscope. These are things, we're in the vineyard 6 months out of the year. We're making wine in the fermentation room 2 months out of the year. We should be looking at microbes 12 months out of the year. The problem with your nose is if you smell the problem, it's too late. By using the scorpions, you can detect their populations before they reach that critical mass. And sometimes microbes aren't microscopic at all. They can form biofilms, bacteria, yeast. These are things you don't want to see. This is the top of a barrel. This is actually not bad, but these are aerophilic microbes that are at the surface of the barrel that will grow eventually into a full biofilm like this. They'll smell nutty and funky. By topping this and keeping the sulfur up, that population should remain and eventually deplete. This is a problem looking down at the top through the top of a tank. If you don't have that tank tippy top, that huge cavity of headspace, no matter how much you gas it with inert gas, it's going to have oxygen in it, and the biofilm will form and eventually start impacting a funkiness into your wine. And these bad microorganisms, they can work together. They're devious. I've only heard of ropey wines. Perhaps some of you have seen this. I don't believe it's happened in the United States, but apparently it's a streptococcus and acetobacter working together to form basically filaments and strands in the glass that's supposed to be absolutely repugnant, of viscosity. If your wine is mousy, smells like mouse nest, mouse urine, that's Brettanomyces working with lactobacillus. So, to say that winemaking is just about Saccharomyces and our Enococcus, you're forgetting the ugly side of the picture that really has to be managed. And in parting, this is my last slide or two. I just wanted to touch on uninoculated versus inoculated because I know that I could have really focused this presentation just on that. And instead, I'm just giving it a quick nod. But really what I'm looking for when I'm doing our uninoculated is I want to capture complexity from the wild yeast. That can work in my favor. It can work outside my favor. It's unpredictable. That's why I go, it's not really my drive for wanting to do uninoculated fermentation. This is it. Capture the complexity of your winery Saccharomyces cerevisiae strains. I talk about Saccharomyces cerevisiae like it's just one same life form wherever it's found. Well, there's just like clones of Pinot Noir. There's so many different strains of Saccharomyces cerevisiae, and I looked so hard to find scorpion analysis of a breakdown of the DNA of different strains of Saccharomyces through an uninoculated fermentation. But in a nutshell, I would imagine we have dozens of Saccharomyces strains here in the winery that inoculate our tanks when the grapes arrive. At the start of fermentation, one yeast strain might have a high population. Several others might be low population, and a couple of others with significant populations. By mid-ferment, some of those populations will be gone. Some will arise in different concentrations. And you get this wonderful co-fermentation kind of dynamic going on where you're getting the impact and sensory qualities of several different strains, if not dozens, throughout the fermentation process. But almost inevitably by the end of fermentation, one strain is dominant. And if your winery uses commercially purchased yeast or has in its history, odds are several of the strains that are your native flora are actually strains like D254 and Rhone 4600 yeast strains that are used. They stick around even after you use them, which is why we try not to bring in at all commercial yeast strains because they will contaminate and embed in our flora. It can be risky, without a doubt. Possible off flavors through your wild yeast. If you're not confident in your primary Saccharomyces strain, you might have stuck ferments. That's how winemakers get fired. You do not want a stuck ferment to stick on you because getting it to start is going to be an absolute nightmare. You're greatly increasing, with all those pictures of that guy with his pants, poor guy with his pants down. You're greatly increasing your risk of microbial spoilage. Last slide. This is a beautiful fermentation graph that I think is just kind of nice to kind of wrap things up. I'm old school. I like to plot with a pencil and a ruler. so I can see my fermentations at a glance. Here you have, on the x-axis, you have time in days. Here you have your Brix, your measure of sugar. Here you have temperature, Fahrenheit. The day we receive the grapes, we're at about 23 Brix, 23.5. I do a cold soak, so I chill that, the temperature is flatline because I'm chilling it to less than 50, around 46 degrees Fahrenheit. After the cold soak of 3 or 4 days, I turn on the heat on the tank and I warm it up to about 56. And then turn off the, oops, oh no, nope, not yet. Then I turn off the cooling. And then at this point, this is your utopia phase, right? By the time you get down to about here, this is your sugar, right? So here, sugar is not depleting, so you're not fermenting, right? By the time you actually see this dipping down, you're starting to develop significant yeast populations. By about this point onward, your native flora, your wild yeasts are dead, or they're not contributing anymore. I'm not heating the tank at this point. This just shows the massive amounts of heat generated. As the quicker this line drops, the higher the populations are, the quicker the heat accumulates. And this is so critical. I use the tea bag analogy because the grape skins have your color and your tannin, and you want to get that heat because it'll take much longer to extract those tannins in cooler temperatures, like iced tea, for instance. So you really want to get that heat capping at about, and this is the cap temperature. So I got this over 90 degrees Fahrenheit, which is right where I want to be. As the populations diminish, less fermentation, less heat drops. And then at this point onward, your Saccharomyces are gone and you're now in scavenger zone. This is where you need to get your malolactic bacteria in. It doesn't carry out post-fermentation. But this is where you want to get your malolactic bacteria in at all before anything else has a chance to get in there. I hope I didn't thoroughly confuse you guys. There's kind of a whirlwind. I got really intimidated by the scope of what I was presenting. It does not do microbiology justice to condense 4 years of education and 16 years of experience into 30 minutes. But in a nutshell, that's really, what we look at it from a production standpoint. That's what I got for you. A couple of nice bottle shots, a palate cleanser to get those vultures out and terminators out of your mind. Hopefully you've had a chance to try our wines, and if not, hopefully you will soon, or look us up. But it's been a pleasure to be here with you guys. I know we're doing a Q&A. I'm not leaving, but I hope you enjoyed it.
Thank you so much, Matt. This has been extremely educational, and more so the interaction of various microorganisms. I think that's where I found it so useful. I'm sure everyone else did as well. So we have, sorry, I'm just going through all the questions here. So the first one was from Beverly. Beverly, would you like to ask the question about what you were asking about the vineyard not having an environment, or?
Sure. Hi, Matt. Great. Oh, hang on a second. Sorry, I don't like to be hidden. Hi, thank you so much for the presentation. It was just, it was quite a whirlwind, but it was great. I'd like to watch it again, actually. I'm sure a lot of us will do that, but it's fantastic. So my question really was, just as you were talking about Saccharomyces cerevisiae, being hard to find in the vineyard, I just found myself wondering, well, I thought maybe I should know this, but why the vineyard is a relatively inhospitable environment for Saccharomyces cerevisiae compared to other things.
Yeah, that's a wonderful question. I know that Saccharomyces cerevisiae is not akin to sunlight, and we very deliberately expose our clusters to sunlight, especially in the Pacific Northwest. It is a different must have had a totally different evolutionary pathway. It's not akin to the surface of the grape skin, like the Mechnicalias, the Turuliosporas, and all that. The short answer is I don't know, and I don't know why it's not found there. If it didn't, I believe it must have originally come from the vineyards, right? I mean, where did it come from? Winery, where did the first winery, where did it get its use? It must have been the vineyard. But there's a lot of instances, just to reinforce this, where a new winery opens, and I was at a place in upstate when I was working in upstate New York, in the Finger Lakes area, and a winery opened up out of a barn. It was a retrofitted barn that had livestock in it. And I was there visiting as they were setting it all up for their first harvest. And they're like, oh, we're going to do native uninoculated fermentation. I'm like, oh, you know, you don't know what's there. I strongly suggest you don't roll the dice on that one unless you have stuck ferments, because there's been studies where they pick the grapes of a commercial vineyard, process the grapes in the vineyard, and then process another batch of those grapes at the winery. The grapes that go to the winery start fermenting immediately, whereas the grapes in the vineyard really tail off and often don't finish fermentation. That could be for various reasons, but the most logical of which is that Saccharomyces just is not there. And I'm sorry I can't specifically answer that directly as to why they're not found on the skins. All I can attest to is that a lot of people insist passionately that they do exist on the skins and they do ferment. And I'm not trying to discredit them. They can believe what they want. I can believe what I want. But my professors at college, my colleagues in the industry, I come across fewer and fewer people who actually make the claim this wine was fermented from yeast isolated from our vineyard.
Thank you.
If you're winery,
sense, doesn't it?
If you're from a winery with a lot of history, if you're Burgundy, your house, I think it's all your house strain. That's my sense, is that what makes uninoculated special is your unique concoction of house Saccharomyces cerevisiae. If you take grapes from a vineyard and bring them here versus another winery down the road, you're going to have totally different, yeast population profiles, different characteristics. You can't replicate it. So it's a similar in that, you can't replicate our yeast from our vineyard. But I think it's not the vineyard, it's just the winery. But that makes you unique. But what it doesn't make unique is if you're bringing in, different vineyard blocks, they're all going to get the same yeast if they're all going to the same endpoint, right? But some people like to make the claim like, oh, we brought this in from this place, brought it into the winery, fermented with that vineyard yeast, and then this place from this separate and totally different yeast over here. Yeah, maybe.
Very interesting. Thank you so much, Beverly. Meg had a question which you probably did answer to some extent. Meg, would you like to ask about the pied de cuve?
Well, I had a question about whether you ever did a pied de cuve. I think you did answer that question, but I guess if I may, the question I have following on your last statement is, do you view the winery then as a part of the terroir of expression of your wines?
Ooh, yeah. The terroir, it's when it's so uniquely tied to the site of the winery versus the origin of, you could certainly make that claim if you believed that the yeast were coming from that specific site. I wouldn't make that claim. I believe we achieve terroir through, I actually kind of like it. Stylistically, we do a lot of single vineyards that I want to enhance terroir and the sites to speak for themselves. I like it that I make pretty much all 14 of our Pinot Noirs in a very similar fashion. Not a lot of enological wizardry, same fermentation management, same barrel aging regime. I want the terroir to be the differentiating factor. And if the yeast are the same, principally across them, that's fine. It just really means it's the dirt doing the talking, in my mind.
Thank you.
Thank you. And then we have lots and lots of us who have really enjoyed. Matt will have to go through. Everyone has thanked you for this wonderful presentation. Christina, Heather, Winnie, Richard, Meg, Reva, everyone has had such a fabulous presentation. Neil, Liz, Ruma, Heather, Elizabeth, Heather, there is Caroline, Susan as well. And then I'm just quickly going through. Jenny has also said fabulous, brilliant.
Yeah, keep it coming, keep it coming. I like it.
Caroline has a question. Caroline, would you like to ask a question on the cultured ML of bacteria versus wild?
Yes, I'm interested in, you touched on malolactic and the importance of getting it going pretty quickly after the alcoholic fermentation. Does that mean that you use malolactic cultures, or do you hope for the best with native cultures of malolactic? And if it's native cultures, do you have any concerns about histamine formation as well? So two-part question.
Yeah, I gotta be honest, you guys ask the most technical questions. Talking with Sumi, I love it. You guys know your stuff. I'm used to talking to consumers and salespeople, and they know a lot too, but they don't ask about histamines. Our malolactic, I don't use commercially purchased malolactic bacteria. Malolactic bacteria, I mean, you saw those scorpions of the finished wine post dryness and sulfur, where there were millions of cells of malolactic bacteria still viable in that finished wine. That, like the Brettanomyces, like the Saccharomyces, is pretty dang resilient to where it's never leaving your winery. Our malolactic strain has lived here for decades. Maybe it's evolving. I'm sure it is. I can reliably say that all the barrels that go through malolactic are using our house strain, much like we're using our house Saccharomyces cerevisiae. I don't tend to deep dive into the productive characters. When I was using commercial yeast and commercial bacteria, which is now going on 6 years, you look through, I don't have one, but these enological books where you're buying yeast and it's a catalog, and you're like, this has high production of this, high production of diacetyl. You're looking at all the yeast strains you can buy if you're doing a commercial fermentation. It was actually quite fun. I was like going through a toy store, what kind of malolactic strain do I want, where you can dial in what you're specifically looking for in terms of different characters that it produces over the course of fermentation. When you're doing the native approach or the uninoculated approach, and you're getting good results, I pretty much just said I'm happy with what it is and I'm good with that amount of knowledge. So I'm not being selective.
Okay, thank you. And while I've got you, quick second question. I'm curious as to that you feel that using chitosan is less interventional than using filtration, if I've understood your approach correctly. Do you care to comment on that for me, please?
Yeah. So chitosan, you're physically adding something to the wine. I do trials. I've never had a taste impact of chitosan in and of itself. It's essentially inert. It doesn't react with the wine. That it binds and it's heavier than, it binds to the microorganisms and precipitates out, means there's none of it residually left. The impact it has on the wine, which I would say is unfavorable, is that it forces you to rack. If you add the chitosan, it'll bind all the bacteria or the Brett or whatever else you don't want. But after a period of maybe 4 to 6, 7 days, 10 days, the bacteria that it trapped can start to escape. So if you if you add your chitosan, you don't rack off the clean wine off the top, and do order, those microorganisms will re-release and you'll just be left with, chitosan holes at the bottom. So it's forcing your hand to rack, which no matter how much gas you use, you're getting rid of your lees, right? I love lees. I love having Saccharomyces cerevisiae down below, forming a thick, muddy layer that just wants to release those polysaccharides back into solution. I even like to do batonnage on aging Pinot Noir barrels and kick up that lees and get that texture by resuspending those idle and dying yeast. If I had to rack, I'd lose that possibility. So no, chitosan is just a last ditch effort. With regards to filtration, it's more practical because we don't even own a filter. But filtration is also, chitosan is unique to microorganisms. It doesn't find tannins. It doesn't strip anything out. Filtration purists would say the same. It really depends on what kind of filter you're using. If you're using a diatomaceous earth like the old days, or plate and frame pad filtration that can give your wine a papery taste, those are definitely invasive. But if you're using something like a crossflow, those can be so gentle that they can be very little impact to where it's almost an apples to apples. But if you're filtering, you're also doing that transfer anyway, and you're losing that lees just like you would with the chitosan, because that lees is not going to make its way through the filter. So effectively, those two cancel each other out in terms, one's not better than the other. You're still transferring the wine from A to B, racking out of the dirty stuff or filtering it to a clean tank. So the transfer happens, the loss of lees happens, but you're filtering out extra stuff with the filter.
Thanks.
it's super expensive stuff. It's not economical. The chitosan is super, super expensive. It's almost the same cost. If I'm adding a ton of chitosan, and I have had to do that, the accounting team is barking at me. You need to stop spending, buddy. It's not cheap. Microbes are not cheap. That's why I like to challenge, people that say, uninoculated is cheaper. You're not buying commercial yeast strains. Commercial yeast strains are cheap, and I can tell you what's not cheap is having to run scorpions on all your wines periodically, and the risk you inherit. I've lost tanks. I'm not too proud to admit it, but I've had tanks that just have developed so much ethyl acetate from those Hemsenia spora populations that the smell of the fingernail polish remover is so pungent that and it's a volatile aromatic, that it persisted all the way through 16 months of barrel aging. In the instance I showed you earlier, we got the Saccharomyces in there earlier. I learned my lesson, it blew off. But you can lose, and I believe if you do a commercial yeast right away, once you crush the grapes into a tank, those wild yeasts aren't going to do any of that action. They're going to get dominated, because when you're adding commercial yeast, you're adding billions. You're adding an invasion force. There's no buildup of the Saccharomyces cerevisiae. And I feel like I've gone on such a long-winded response. I already forgot your question. Hopefully that answered it.
Well, thank you. Thank you so much for that. And then again, lots of positive responses. Michelle, Peter McCombie, Master of Wine, everyone has loved it. I think we have time for just one quick question from Christine, which is potentially the last question too. So sorry, Christine, if you're there, would you like to ask a question?
Sorry. Can you hear me?
Yes. Hi,
okay.
Christine.
If you've got a new winery, presumably you've got no local yeast population. So do you then just buy in commercial yeast? And if you do, does that then set the strain and the population of your local yeast forever?
I knew that was coming, Christine. And I've been I'm like, oh crap, someone's gonna ask that question. Presumably yes. You buy a commercial strain right on day one, that's going to become part. The first year you're going to have a tremendous amount of difficulty getting your fermentations going. I think a lot of people, if you're building a winery, are going to recommend, myself included, that you use a safe commercial strain and don't roll the dice. But certainly by the time you use commercial yeast strains, which are engineered, it's selected in the lab for extremely high ethanol tolerance and durability, they're tanky. They're not going away, which is why, in a place that's committed to not adding commercial yeast, I don't want any commercial yeast in this building. But I also acknowledge that when another winemaker comes into our winery, he's covered in the bugs, or she. And I just don't think you can control your house population. It's just your unique stamp that's evolving. If you start out with a commercial strain, that could easily evolve. I don't know that I can't answer that any better than that, because that's a frustrating question, a very good question, but a very frustrating one, because it's logical. What came first, the chicken or the egg? How I guess I'll leave it at that, because I don't have a better answer for you.
Okay, thank you.
The conundrum.
Fantastic. We've had a brilliant start of 2021 with your well-presented, in-depth and quickly rushed through, but also equally covered in detail to the extent that our nerdiness can take in. But thank you so much. I know this is a topic that can keep everyone kind of stuck onto the computer and talking to you for ages. But if you have any questions, do send them through to Andrea, and I'm sure she can send it over to Matt for any clarification. But thank you so much once again. This has been great. And thank you to all our viewers who've joined us, all the members and the friends who've joined us. This has been a fabulous, fabulous presentation indeed.